This is blood spatter part 2. Here are some basic terminology that you should know as we are talking about blood. We've got angle of impact, blood stain transfer, back spatter, cast off, and directionality. I'm not going to read all these definitions to you because you can read, and we will be discussing them in class. This is an example of forward spatter. Forward spatter is just that. The spatter flies forward. So the mannequin's head is filled with blood, the gun is shot, and the blood goes flying forward. But at the same time, some of it flew back at the suspect's hands, and you can tell the directionality of these drops, and you can see which way the blood was flying. We will do a lot more with that in class. The way blood dries can tell us a lot about time. Drying is going to start the moment blood hits the air, and it dries from the outside, the periphery, and goes in. Drying time is affected by all kinds of things, including what type of surface it's on, how much blood. One little tiny drop is going to dry much faster than a pool of blood. The conditions of the air. Is it wet outside? Is it hot? Is it cold? Is it windy? And there's this effect called skeletonization. It's in the picture shown there. That's when the outside has started to dry and something goes and wipes through the blood and a ring is left behind. The longer that the stain is left undisturbed, the more dries and the less skeletonization you're going to have. We will play with that on probably Wednesday. The type of surface that the blood strikes is going to affect how much the blood is going to spatter around, how many spines you're going to end up with. Tomorrow, Tuesday, we will start playing with different surface types, and you're going to try it on floor, you're going to try it on different materials, you'll try it on concrete, and you'll be able to see how the different surfaces affect the shape of the final spatter. Another thing we will look at are the angles involved when blood hits a surface. We will probably start this on Tuesday and we'll finish it on Wednesday. But anytime blood hits at an angle other than 90 degrees, it's going to start making kind of a teardrop shape. And you will be required to be able to tell me if, like the picture in the middle, if that was made at 10 degrees or was that made at 80 degrees. You need to have the rough idea on the angle size. Here's a picture from How Stuff Works. We are going to be calculating the angle of impact, and this is just a little diagram that lets you see how we'll do it. We will be using the arc sign in order to do this, so you need to get a little bit of your trigonometry back in your mindset here. So you may want to be coming with calculators. Here's a little more complicated looking one, but sometimes people can understand this one better. We will talk about this more in class, but if you know that you have some trouble with math, you may want to print out this slide to have it as a reference. Here are some drops at different angles. This picture shows you that sometimes when a drop hits the surface, some of the blood flies away from it. Those of you that did drops at 100 centimeters or higher already, you probably have seen some of it starts to fly away. The tail of that satellite actually points towards its parent stain, the original stain. And remember, the original stain, the tail points in the direction of travel. All right, we've got different types of blood spatter. We have passive, which is what we've been dealing with, where gravity is the only force involved. And the next one is projected. Projected is when an additional force is added to it besides just gravity. And here are 4 different examples, and we'll go through each one real quickly. The first one we'll look at here with projected is arterial spray. Sometimes it's called arterial spurt or arterial gush. This is when a artery gets cut and all that blood pressure ends up pumping the blood out. Here's some pictures. Low velocity impact blood drops are from a force that is not all that much greater than gravity. Technically, even gravitational drops are considered low velocity. They tend to be larger drops than a medium or high velocity impact. So here's a hammer just smacking into some blood. That is going to give us low velocity. This will make a lot more sense when you actually see it in class. Here are some gravity drops. Again, it's just low impact. You're not really flinging the blood hard. Cast off is an example of low velocity as well. Cast off is when somebody goes and takes a hammer and hits somebody on the head. Well, they're not done. They lift that hammer back up over their shoulder and they fling it back down and smack the person again. The first time they hit the person, there was no blood except for when it actually impacted the person. But when they lifted it up over their shoulder, some of that blood might have flung onto the wall, onto the ceiling, onto the floor. And then when they swung it back towards the person, more blood would have flown. And then keep flinging back and forth. It makes these little trails that you can follow on the ceiling or on a wall. You can actually figure out how many times the person was struck from counting all those. You do have to include one of them, though, because of the very first hit having no blood. Here's a picture. It's kind of hard to see on here, but they're able to figure out which way the blood was flying. Here's some more what cast off would look like with some different weapons or tools. It gives these little trails. All right, medium velocity. These are going to get a little bit smaller droplets than the low velocity. You do not need to know how fast they travel, but they travel roughly between like 5 and 25 feet per second. And so the drops are getting smaller than the low velocity. And so here's just some pictures. Here's smacking really hard, some blood. Sometimes it leaves these little tails. Anybody figure out which direction that was traveling in? We'll figure that out in class. High velocity, the best example of high velocity is gunshot wound. That bullet, when it hits the person's body, the blood flies out in a mist. It is traveling really fast, and the mist is actually really fairly small. So the faster the blood travels, the smaller the droplet. Here's some more misting. A bunch of misting pictures. That's kind of zoomed in, but you can see the bullet hole in the middle. The next thing is voids. Voids are really important. The criminal case that I was on the jury for, there were voids in that one, in the fire, not blood, but voids let you know when something is missing. So in this case, that cooler was there whenever this crime occurred, but somebody took the cooler away, leaving a void, an empty space.